Okay, guys, so we are on our second to last set of notes of this unit 2, which now we're going to be working on inequalities. So, guys, with this one, there's going to be a lot of different shading and lines that are going to be happening, and it's going to go a lot off of what we've already talked about before in regards to our less than, greater than, less than or equal to, greater than and equal to signs, because it's actually going to determine how we're supposed to shade. So first thing, we're going to talk about our steps. So first step is to graph each linear inequality. And we're going to go over that. It's very similar to graphing our linear equations. It's just the difference in what we're looking at. So when we see, if we're going to draw a line or a dotted line. So when I'm talking about the line, you know, when we drew our linear equations, we just drew a simple line with an arrow. Well, that's not always going to be the case right now, because in some instances, you're going to have where it's less than or greater than, and it's going to have to be a dotted line. So that's going to be da, 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 and then you have your arrows. This means that it's not included, same as when we are doing our equations. They're not included. Now, if we have less than or equal to or greater than and equal to, that's going to be a solid. So that's going to be what we're used to seeing right here. And then we still have another thing we've got to worry about, and that's where we're going to be shading. So if we have less than or equal to, you're always going to shade below the line. And if you have greater than or equal to, you're going to shade above the line. This will make more sense as we actually start doing some of the graphs, so bear with me. This right here, guys, again, is just a little more detail if you want to understand it a little bit more. So graphing the corresponding line represented by an inequality is going to be, first you're going to rewrite it into slope-intercept form, which meant, again, guys, we've talked about that, which is just going to be your y equals mx plus b, or in this case, y less greater than mx plus b, enter any of the interchangeable less than, equal to, greater than, equal to. That's what we're saying when we're going to rewrite it in slope-intercept form. Then, as we already talked about, a dotted line will be used for these symbols, and a solid line will be used for these symbols. To determine which region to shade, so you've got two options on this version. So you've got the up-down method, which means basically the inequality must be written in the slope-intercept form, which we want anyway. And so for any of our greater than, you're always going to go draw your arrow straight up from the line, meaning you're going to shade above it. And with our less than, you're going to do the opposite. You're going to draw arrows down and shade that reason. Your test point, we're not really going to do that one as much. It's basically selecting a point from the region above or below the line and evaluate the inequality at that point. This one's a lot more work, and I would suggest you sticking with this method. Okay, so there's a two-variable system of equation. It's not going to be as much as what we need again, but it's talking about when we have no solution or if we have multiple solutions. So graph all linear inequalities belonging to a given system. The solution region for the system of inequalities is comprised of the region where the shaded areas of all the systems overlap. So you'll see that in just a minute. We're going to have a lot of systems overlapping, and that's where I'm going to be doing different colors. So a system of inequality has no solutions if there's no regions where all of the inequality shaded regions overlap. So that's when we're going to have our no solution, is when there's no areas that overlap. So steps for writing a systems of linear inequalities for graphs. Basically, you're going to use the graph to determine the equation corresponding to an inequality. Basically, what that means is you're going to represent an equation as an inequality in slope-intercept form using the correct inequality symbol, which are symbols we've talked about before. Basically, if it's shaded above, you'll use your greater thans, and if it's shaded below, you'll use your less than or less thans. And then you use the different ones for your solid lines or your dotted lines. And again, we're going to talk about those as we actually go through it, and you'll repeat for all of the different linear lines. So now we're actually going to graph each system of inequalities and then give a solution to the system and tell what quadrant it is. So before I even go into that, we're going to make sure we remember the quadrants. So it's 1, 2, 3, and then 4. So it's going counterclockwise, meaning backwards on a clock. Okay? So that's our simple thing right there. So everything I do with my lines, I'm going to do in my black. And then my shading is what's going to determine our difference. So my first equation, the first thing I want you to notice is it's not in slope-intercept form. So that's what we're going to switch. So we have x minus 2y less than 6. So I'm going to minus my x to both sides. And then I've got my negative 2y less than negative x plus 6. Okay, this is where a lot of y'all are going to forget our rule. But if most of y'all remember about inequalities, if you divide a negative by both sides, that means your sign is going to flip. So you're going to end up with y greater than 1/2 x minus 3. So you flip the sign every single time. So when you divide by a negative, you flip your sign. So now we have this equation, and now we're going to put this onto our graph. So I'm going to zoom in a little bit. So this is the same thing as when we're graphing before. So we start with our y-intercept, which is going to be my negative 3. And so I'm going to start at negative 3 right here. Before I start doing anything, I'm going to look at that slope. So it's positive slope, so that means my line is going to go this direction. So I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. And then same thing to make sure, down 1 to the left 2, down 1 to the left 2, down left, down left. Okay, before I just start drawing a line, I need to make sure that I know where my line is actually going to be. The reason I say that, guys, is this sign right here. I'm going to circle it in blue. This means it is a dotted line. So if it does not have an equal sign, it is dotted, like we put in our notes. So my line needs to look like this, all the way across with my arrows. And that is my first equation. Now I can look at my second equation, but I'm going to shade first, so I make sure I don't forget to shade this one. So on our first rule, it said to use the arrows. We have a greater than, so remember greater than. That means everything's going to be shaded up for it. So I am going to just point arrows up, all the way up on this one, so I know that I am above this line all the way through. And it's in red. Now, I'm going to draw my next equation in black. So, I'm going to start with my 5. That's my y-intercept. It's right here. And then I'm going to go, it's a negative slope, so I'm going to go negative 3. 1, 2, 3. And then over 2. Negative 3 over 2. Negative 3 over 2. This one, the difference here, guys, is it is an equal sign. So that means mine is a solid line this time, all the way through. But if you notice the difference in this line, it is a less than sign, less than or equal to. That means everything is going to be below my sign. So I'm going to do the same thing, and I'm going to draw my arrows going the opposite direction. Everything's going to be down. So now what we're looking at is we're trying to give a solution to the system. So what that means is I'm asking, is 0, 0 in that solution? Our solution is going to be everything highlighted here in yellow, because that's my place where my two sections overlap. This is where my two inequality shaded areas overlap, is in that yellow. So does 0, 0 fall in that? Well, yeah, it does. So that is a solution to our graph. And what quadrant does the solutions fall in? So what quadrants does this section fall in? Well, that's going to be, it has actually all of my solutions. All quadrants are part of it, because you have one right here, 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 and here. So all of my quadrants are actually a part of it. You can have a solution fall in every single quadrant. So that's our first one, guys. We did a lot on that graph to find simply, yes, 0, 0 is a solution, and yes, all quadrants are a part of it. That's fine. So now we're going to do this letter B. So same thing. Our first equation is not set to our liking. So we're going to do negative 3x plus y greater than or equal to negative 6. So I'm going to add my 3x to both sides. And then I get y is less than or equal to 3x minus 6. Notice, I did not switch my sign that time because I didn't divide by a negative. I just added across. So now I can actually mark this on my graph. So we start with negative 6 as our intercept. Then I'm going up 3, 1, 2, 3, over 1. Up 3, over 1. Up 3, over 1. Up 3, over 1. Okay, so this one is equal to, greater than or equal to, so I can draw a solid line through my graph here. And before I move on, I'm going to shade what I need to shade. So this is saying my y is less than, which means I'm going to shade everything below my line. So I'm going to make all my arrows here go this way. Perfect. So now I'm going to do my second graph. So this one's already set up for me. So I'm going to start at my y-intercept, which is 2. And then notice my graph is going to be a negative slope because I have negative 4. So I'm going to go down 1, down 4, 2, 3, 4, over 1. Down 4, 2, 3, 4, over 1. I can do the same thing, go in the opposite direction. Up 4, over 1. Now this one, you can see the difference here. This is not an equal to, so I have to have a dotted line. 1, 2, 3, 4, line, up, up, up. And with this one, our difference again, guys, is it's greater than. So our lines are going to go this way, all the way across. So now I can zoom out a little bit again. My section that is shaded together is right through here, guys. So everywhere that blue and red crosses, that is my shaded region where my inequalities go together. So on this one, zoom in a little bit for y'all, is 0, 0 a solution? No, it's not in our yellow shaded area. But where could a solution fall? Well, that's going to be in the first or the fourth quadrant. Those are the only places you can find solutions. Okay, so we've got 2 more examples on this page, guys. So this letter C over here, we have to determine and put both of these in slope-intercept form. So I've got 2x minus 3y greater than 6. So I'm going to subtract my 2x from both sides. And then I get negative 3y greater than negative 2x plus 6. Then I'm going to divide negative 3 by both sides. See, I'm dividing a negative, so that means I'm going to get y less than, sure you notice that, less than 2/3 x minus 2. Then I've got my other equation, so I'm going to do my 3y plus 1 greater than negative 2x. So I'm going to subtract my 1 to both sides, and I'm going to get 3y less than negative 2x minus 1. Then I'm going to divide by 3. Notice this is not dividing by a negative. So my sign is going to stay put as less than negative 2/3 x minus 1/3. Okay, so 1 equation, 2 equations. So now we're going to do both of them. So first one, I'm going to choose the one we did first. So my intercept is going to be at negative 2. Then I'm going to go up 2 over 3. Up 2 over 3. Same thing, I'm going to go down 2 to the left 3. Okay, this is not an equal to, so it's going to be a dashed line. And it is less than, so that means I'm going to make it everything down. Okay, so now I'm going to draw my next one. So it starts at negative 1/3. So that's going to be kind of about right here. Then I'm going to go a negative slope. So I'm going to go down to 1, 2, over 3. Right here, down 2 over 3. And then going to go up 2 over 3. There, same thing. And it's also a dotted line because it is not an equal to sign. So I'm going to have a dashed line all the way across. This one is also less than. So that means I'm going to do everything below in this blue. So where my blue and yellow cross, that is where the intersection is all of this yellow part. So now my question is, does 6, -4 fall into this? So let's look. I'm going to zoom in a little bit for y'all. So 6 over here, 1, 2, 3, 4. That hits right here. And it's super close to our line, but it's not included. Ours is not included on here. The regions that could be included are our third quadrant and our fourth quadrant. But this one is not included. So no. Okay, so now we're going to work on our next one. Y'all are really going to enjoy this x. So y'all remember when we had x equals 4 and it would just be a line? Well, this is going to be a very similar thing. So when it is an x is greater than 4, you're going to go to that 4 on the right here. And because it's not equal to, you're going to just draw that happy little dashed line. And since it's greater than, we want everything to go this direction. So all my red is going to be over here. Then I've got to solve for this one to make it into my slope form. So I've got 4y greater than or equal to 3x. I'm going to divide by 4. And I'm going to get y is greater than or equal to 3/4 x. So remember, when we don't have a y-intercept, you get to start it at 0. So I'm going to zoom in right here. And we have 0 right here. And now, everything we're going to do is just going to be 3 up, 4 to the right. 3 up, 4 to the right. So doing that, it's going to be very simple. We're going to be creating our new slope. So we have up 3 over 4. Up 3 over 4. Then we're going to do it down just the opposite direction. Down 3 over 4. Same thing, down 3 over 4. Okay, so this one isn't equal to though. So that means we're going to have a solid, lovely line. And it's greater than. So that's going to be different than what most of y'all have seen. So we're going to go blue up all the way across. And our only place that crosses is right here in the corner. So our question is 8, 6. So we're going to go 8 here. 1, 2, 3, 4, 5, 6. So it hits right at our dot here. And it is included because it is a solid line. If it was a dotted line, it couldn't be included. But because it is on a solid line right here, it is included. And all of our answers are going to be in the first quadrant. Okay, so we have a couple more examples and we're done with these notes for today. So now we have 3 equations that we're working with. So we have y equals -3. So I'm going to go down to -3 and I'm going to make my dashed line. And because it's greater than, I'm going to have all of this shading on my red to go up here. But I'm actually going to make this a little different instead of the arrows. Since now y'all understand it a little bit better, I'm going to do the highlighter so y'all can be able to see my lines on my other ones better. So all of this is going to be my above here. So then I have my x is less than or equal to -2. So I'm going to get my -2, and since it's an equal to, I can give my solid line here. This one, I'm going to make it completely blue. And everything's going to be less than, so it's going to be all right here. So you're already seeing a trend of where we overlap. But we still have our last one to do. So we have our slopes, our intercepts start at -5. Then we're going to go up 3, 1, 2, 3, over 1. 2, 3, over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. We can go down 1, 2, 3, over 1. This one we have to make dotted because it is not an equal to. But it is greater than. So we're going to make this one green. And we're going to shade everything above that line. So the only place that all three of these cross is over here in that second and third quadrant. So that's all we had to do on this one was shade it out and answer our stuff. So my answer on this would be that anything in the second or third and part of the third quadrant could give us answers right here in this little area where it's all shaded. So now we're going to do the same thing on F, but we're going to have 4 different equations. So first one I'm going to switch to, it's going to end up being y greater than 2x minus 2, y greater than or equal to 2/3 x minus 7/3, and then y less than x plus 5, and then x greater than -7. So I'm going to start with my x just because it's on the bottom and it's easy. So I go -7, it's going to be a dotted line, and then it's everything greater than it. So I'm going to make that green, just everything over here. Okay, and then I'm going to go to my next one. So it starts with our plus 5 here, and then it goes up 1, over 1, up 1, over 1, down 1, over 1, down 1, over 1, because it's just the x is the slope. Okay, so it's going to be dotted again because it does not have an equal sign, and it's everything less than it. So I'm going to put that in blue, and it's going to be everything less than it. So all of this section is going to be included. Perfect. So now I'm going to do my third one. So it starts at about 7/3, which is about 2.5-ish. So we're going to put it right here. And then it goes up to 2 over 3. Up 2 over 3. Down 2 over 3. Down 2 over 3. And this one has an equal sign, so we can put a pretty nice line all the way through it. Okay, and then we have one more. It is going to start at -2, and then go up 2 over 1, up 2 over 1, up 2 over 1, all the way through, and then down. Down 2 over 1, down 2 over 1. And that one's going to be a dotted line as well. So I didn't do mine on the last one. So I've got to actually do my next one, which was in red. And it should be everything above my solid line, which is all here and here. Then my last one, I'm going to do in this grayish color, is going to be above my last line I just did. So it's all right here. So that means this little red space right here is where it is, which actually hits in about all the quadrants. Okay. So the last thing is doing the exact opposite. So we're writing the inequality. So we're going to look at this dotted line first. So our dotted line, this little section is going down. So that means it has to be a less than y. Now I just have to make my equation. So it starts at a -3, so I can put that as my y-intercept. Now I just need to find the slope. So I'm going to go up 1. Can I go over? Oh, it hits my mark. Up 1 over 1, up 1 over 1. So then I've just created my first equation. Now I'm going to look at my solid line. So my solid line is actually going up right here. So that means it has to be greater than or equal to y. This line starts at +3. Now let's see. It's going to go down just the same, but we're going to have a -x. So that's going to be our 2 equations right there. So all you're doing is going through your different lines. So this last one, we're going to start with that dotted line. So it's going down So that means it has to be y is less than. So now we just look at our intercept. So we have in 2 as our intercept. And then it looks to be about, we go up 1, and then it looks about 7. So we're going to go about 1/7 x. This may be a little bit harder to look at, but that's okay. We're going to look at this line now. And this one's going up. So that means it's going to have to be y is greater than or equal to. And it looks like our intercept is at +1 right here on this little dot. And then we need to have a negative slope. And then it looks like it's going down 1, over 1, down 1, over 1, down 1, over 1. So it's that negative x. Our last one, it's going up. So it means it needs to be y is greater than or equal to. It's a positive slope. And it looks like our intercept starts about negative 7. So we had our -1, 1. So let's look here. So it's going to go 1, 2, 3, 4, 5. And then over 2 is about where we can see it. So it's about 5/2x because it's a positive slope. These may be a little bit harder for you to see, and that's okay, but that's how we're going to look at them to start. And that is our inequality notes. So if you do have any questions, please feel free to come into AP.